Okay guys, welcome back. We're going to start up a new section today. It's R.7B in the review packet. So today we're going to talk about the relationship between radicals and exponents. So rational exponents we typically define as they can be whole numbers or fractions, even negatives. So we can use the definition of rational exponents to convert back and forth between radicals, radical notation, and exponential notation. So here's some very, what we call abstract examples, and then I'll show you some concrete examples. So in number one, if you have a to the power of 1 over n, that can be converted back and forth between the nth power of or the nth root of a. So let me show you what that means. Is say if I had the 25 to the power of 1/2. Very confusing, right? But if you convert it over to a radical, it becomes, the denominator becomes the index, and then you don't need the 1 when it's a numerator. So what it turns into is of course, when it's a 2, that's the square root, and the square root of 25 is 5. So you can use these properties to your advantage to help you solve problems easier. Let me show you another example. So if we have 2 to the power of 1/3, you can turn that into the cube root of 2. And unfortunately, the cube root of 2 does not simplify any further, but I at least showed you to use the property of how to convert it over to a radical. So number 2 is very related to, very similar to 1. It's that when you have a fraction, again, the denominator becomes the index. And if you have a numerator that's not 1, you can either place it inside the radical with the base a or outside the radical. So let me show you an example. So say if I give you x to the power of 4/5, and I tell you in the directions to turn it into radical form. So you would turn it into the 5th root of x to the 4th. Or you can write it this way as well, and it's the same thing. Number 3 reintroduces an old exponent property that says our answers are not allowed to have negative exponents. So remember that you would make it a fraction or reciprocal, and move the a to the bottom of the fraction, making the exponent positive, and vice versa. So here's another one. If you start off with, say, 1 over x to the power of -3/2, we don't want a negative exponent in answer, so that would mean it would have to move to the numerator, and then since there's just a 1 on the bottom, we don't need the fraction anymore. Okay, so example 1, I'm going to convert to radical notation. So the bottom is, the denominator is 4, so it's 4th root of 7 to the power of 3. Letter B is a negative exponent. I want to get rid of that first, so I'm going to make it 1 over 8 to the power of 5/3. Then I can turn it into radical notation. So 1 over the cube root of 8 to the power of 5. Now, with this, my goal is to convert to radical notation, which I did. If it were to say to simplify, I'm going to show you how to do that. You can actually simplify this because if you take a look, cube root of 8, what is the cube root of 8? It's 2. So the cube root of 8 is 2. Carry over the 5, and then it's 1 over 32, because 2 to the 5th power is 32. 2 times 2 times 2 times 2 times 2. All right, letter C, very easy here. Actually could have started with that one. That would be the 6th root of m to the 1st, but you don't need the 1, so you'll just have 6th root of m. Letter D, please don't do the reciprocal. It's not the same as B. The exponent is not negative, it's a positive, so do not do a fraction here. Let's convert it over. It'll be a 5th root of negative 32 to the power of 2. And let's try to simplify that. The 5th root of negative 32 is allowed because it's a 5 for the index, an odd number. So the 5th root of negative 32 is negative 2. And then apply the exponent of 2. Negative 2 squared is 4. So we started off again, we converted to a radical, and then we're always looking to see if we can simplify. Okay, now let's do the reverse. In this example, we are going to do the reverse. We're given radical notation. We're going to convert it over to exponential notation. So we have that 5 on the outside. So what we're going to do is the 4th, or sorry, let me back up here. Thinking ahead. We're going to have 7xy in parentheses because it's in the radical, the 7 and the x and the y. And then outside parentheses, we'll put the exponent, 7 to, or 5/4. Letter F, x to the power of 3/6. But we are always looking to reduce. That is a fraction, after all, that can be reduced. That reduces to 1/2. Okay, example 2, we are going to, it's showing multiplication for these problems, so we're going to simplify and write in radical notation. So in letter A, we have x times x. Remember, we are supposed to add their exponents. So if we add them, that will be 5/6 plus 4/6. 2/3, change both numbers, times 2, and that will be 9/6. However, we're not done here. 9/6 is a fraction. Divide each number by 3, and we'll have 3 over 2. Now that it's simplified, we can now turn it into a radical. So 2 on the bottom would be square root with the invisible 2 of x cubed. Letter B, this is technically x plus 3 times x plus 3. We're going to use the same rule as letter A. We're going to add the exponents. So 5/2 plus negative 1/2 will be 4/2. And actually, that fraction just gets 2. Now, since we do not have, I mean, you could, if you were to turn this into radical notation, you couldn't do it with the whole number 2. What we would have to do is we'd have to go back and we'd have to stop here, because the lowest denominator you can have to turn into a radical is a 2 for square root. So this would be square root of x plus 3 to the power of 4. Okay. So the next one, very, very tricky problem. We have a cube root, you would say the cube root of the square root of 7. Very intimidating looking problem. What we're going to do is split it up. We're going to start with a 7. Again, it's tricky because what we're going to have to do is turn it into exponents and then multiply them and then turn them back into a radical. So the immediate 7 inside is a square root of 7, so that is 1/2. So it's saying 1/2 to 1/3 for the cube root. So we're supposed to multiply the exponents, and that'll be 1/6. Now that it's down to one exponent, that means that we can get it down to one radical. So that would be the 6th root of 7 to the power of 1. So definitely a tricky problem there. Just remember, try to commit to memory that when you see those radical inside a radical, you're supposed to multiply some exponents. Okay, example 3 is actually down here. We're going to write an expression containing a single radical. Now, at first glance, it is showing multiplication, but remember, you can't multiply a square root times a 6th root. So what we have to do is we're going to turn them into exponents and then multiply them. So the first one, square root of a, that's a 1/2. If there's anything I want you to remember out of today, it's square root is 1/2. And then the b will get a 5/6. And then what we can do is actually, I'm sorry, earlier I said multiply, I did not mean to say that. We are going to get this guy and this guy to have a common denominator. So if you show 2 and 6, that would be 6. So a is 3/6 by multiplying each number by 3. That can now match with the b's denominator 5/6. So now you can put them both in a 6th root. And they would be the 6th root of a cubed b to the power of 5. So we did meet the goal at the top of the page. We wrote an expression containing a single radical. All right, guys, please be patient through this lesson. As you're noticing by now, it is pretty intense and confusing. Just take your time. Rewatch and rewind as you need to. All right, let's get some more examples in. So our goal here is going to be to convert to radical notation. So that would be the 5th root of 32 to the power of 4. What we can do is do the 5th root of 32. The 5th root of 32 is 2. Carry over the power of 4. And then 2 times 2 times 2 times 2 is 16. So the answer is 16 after simplifying. So here is converting to a radical, and then we went further and simplified. Even though it didn't say simplify, we still did it anyway. Number 2 has a negative exponent, so let's make a fraction. 1 over 8 to the power of 2/3. Make it positive. Now turn it into a radical. 1 over the cube root of 8 squared. And always try to simplify it. The cube root of 8, you guys should have that memorized by now 100%. That's 2, because 2 times 2 times 2 is 8. Carry over the squared, and then that'll be 1/4. Number 3, should have started with that. It's the easiest one, just the 5th root of b to the power of 1, which is the 5th root of b. You don't need the 1 there. And number 4, that would be the cube root of 27 squared. What is the cube root of 27? It is 3. 3 times 3 times 3 is 27, so it turns into 3. Bring over the squared, and then 3 squared is 9. Number 5, we are going to write each of the following in exponential notation. So we have 4ab in the radical, so let's put 4ab in parentheses, and then 2/3. That was pretty simple. And let's do this one. This would be a to the power of 9/3. This is a fraction. Divide each of those numbers by, actually, 9 divided by 3 is 3. Or 3 over 1, which is still 3. Number 7, we're going to simplify and write in radical notation. So we have been going, I know there's a lot of confusion, we've been going back and forth between the two methods all lesson, so I apologize about that. So here we're going to simplify and write in radical notation. So our goal is a radical. Now we have to use, you do not want to turn it into radicals right away. We want to get it down to one fraction. So x times x, remember we are supposed to add the exponents. Common denominator of 5 and 2 is 10. So that would be 12 over 10, multiply each by 2. And 1/2, of course, is 5 over 10. Now we can add them. That would be 17/10. And now that it's down to one exponent, we can do what the problem asks us to do. We can write it in radical notation. That would be the 10th root of x to the power of 17. Okay, number 8, there was one like this also on the previous page. It's y minus 2 times y minus 2. What do we want to do with those exponents? We want to add them. Very similar to number 7. So that would be 7 halves plus negative 1/2. And that would be 6 halves. Now don't turn this into 3. Don't turn it into a whole number 3. Because if you do that, we can't actually meet our goal of the problem, which is to write it in radical form. So please keep it 6 over 2. You can't do 3 over 1, all right? A 1 as a denominator is not a square root. It has to be a 2 to be a square root. A 2 or more to be turned into a radical. So 2 on the denominator is just a square root with the invisible 2. And then in the radical, y minus 2, and then to the power of 6. Make sure you put the power of 6 outside of the parentheses there. Number 9 is that tricky one, radical in a radical. So on the previous page, we wrote x, and then we dealt with their the inside one first. So the inside one is square root of 9. So that what would that be? That'd be 9 halves. And then that would be to the power of 1/3 for the cube root. And then we want to multiply them. So that would be 9 over 6. We can reduce that. Each of those numbers divides by 3 to have 3 halves. And now we can turn this into a radical. 2 and the bottom means square roots of x, and then numerator, throw it in with the x, square root of x cubed. And wrapping this up with one more problem, we're going to write an expression containing a single radical. We have one like this on the previous page, example 3a, I believe it was. So let's write them as, again, we can't multiply them. We cannot multiply a 4th root times a square root. So we have to use some exponent rules here. So a's exponent would be 1/4 times b's exponent would be 1/2, of course. Now we need to make them common denominators. To have a common index for a radical, you have to have common denominators in their exponent form. So if you have denominators of 4 and 2, that would be an obvious common denominator of 4. So 1/4 carried over for the A, and then the B, what would that be? Over 4, multiply each by 2, so 2/4. So now that they both have denominators of 4, we can write it as a single radical. So 4th root of a to the power of 1, b to the power of 2, and then just get rid of that 1. So 4th root of ab squared. All right, guys, enjoy your day. That's the end of the lesson.